Good day everyone. In this video, we discuss a phenomenon known as shockwave. How is shockwave related to sonic boom? We'll find out if stick around, watch and learn. So what is a shockwave? In the illustration, letter A shown, imagine that an airplane is flying nearly at the speed of sound. As the speed Vs of the airplane approaches the speed of sound V, the wavelength approaches zero, and the wave crests pile up on each other. The airplane must exert a large force to compress the air in front of it. And by Newton's third law, the air exerts an equally large force back on the airplane. Hence, there is a large increase in aerodynamic drag or air resistance as the airplane approaches the speed of sound, a phenomenon known as the sound barrier. When Vs is greater in magnitude than V, the source of sound is supersonic. And figure B shows a cross-section of what happens. As the airplane moves, it displaces the surrounding air and produces sound. A series of wave crests is emitted from the nose of the airplane. Each spreads out in a circle centered at the position of the airplane. Alright? A series of wave crests is emitted from the nose of the airplane. Each spreads out in a circle centered at the position of the airplane when it emitted the crest. After a time t, the crest emitted from point S has spread to a circle with radius Vt, and the airplane has moved a greater distance base of S times t to position S2. You can see that the circular crests interfere constructively at points along the blue line that makes an angle alpha with the direction of the airplane velocity, leading to a very large amplitude wave crest along this line. And this large amplitude crest is what we call a shock wave. And from the right triangle shown in figure B, we can see that sine of the angle alpha, all right, is just equal to base of t, or v times t, divided by vs times t, all right? Or we can say that the sine of the angle alpha is equal to the speed of sound over the speed of the source or the airplane, all right? Sine of the angle alpha is just equal to the opposite side, which is v times t, over the hypotenuse, which is v sub s, v sub s times the time t. All right? So, if you divide vt over bs times t, the time t cancels out, and we are left with this equation for sine of the angle alpha equal to the speed of sound v divided by the speed of the source or the airplane. All right? Shock waves are actually three-dimensional. A shock wave forms a cone around the direction of motion of the source. If the source, possibly a supersonic jet airplane, like in this illustration, or a rifle bullet, okay? So if this source moves with constant velocity, then the angle alpha is also constant. And the shock wave cone moves along with the source. It is the arrival of this shock wave that causes the sonic boom you hear after a supersonic airplane has passed by. In front of the shock wave cone, all right, there is no sound. There is no, inside the cone, all right, inside the cone, a stationary listener, okay, will be able to hear the Doppler shifted sound of the airplane moving away. All right. Now, the ratio B of S over V is called the Mach number. All right. In other words, if you're going to express or get the what we call reciprocal of the value of the sine alpha, it's going to be Vs over V. All right. And this ratio is called the Mach number. And Mach number is greater than or equal to unity for all supersonic speeds. And that sine alpha, as I said earlier, is just the reciprocal of the Mach number. Our first question, question number 1. What would you hear if you were directly behind or to the left of the supersonic airplane shown in the figure? All right, so we have here an illustration of our scenario. There's a supersonic airplane at an altitude of, for example, 8,000 meters. And it's moving at a speed 1.75 Mach. All right. By the way, when you say Mach number, it specifies the speed of the source, such as this airplane. Okay. How many times does the speed of the airplane, or how many times is the speed of the airplane compared to the speed of the sound? So that's another way of saying Mach number is just the ratio of the speed of the source of the sound, like an airplane or supersonic airplane, to the speed of sound. That's exactly what is represented by the Mach number. So in this question, um, we are looking for, or we are asked to choose among these four choices. Okay, if you happen to be exactly behind the supersonic airplane, like if you are here in this point, okay, what would you hear? All right, what would you hear if you are directly behind the supersonic airplane, moving at Mach, for example, 1.75? So the choices are, you are going to hear a sonic boom, just like if you are here on the ground, stationary at this point. For letter B, you are going to hear the sound of the airplane Doppler shifted to higher frequency. And option letter C, you are going to hear the sound of the airplane Doppler shifted to a lower frequency, F. And the last option, nothing. You will not be able to hear anything. All right? So, which among these four choices is the best answer? Okay, the best answer is in fact letter C. The sound of the airplane Doppler shifted to lower F. Why is this so? Let's find out in just a little while. Alright, so why is our answer letter C? You will hear the sound of the airplane Doppler shifted to a lower frequency. Our explanation. The figure shows that there are waves inside the cone of the shock wave. Alright? Behind the airplane, the wave crests are spread apart. Alright? So, the waves reaching you have an increased wavelength. Okay? The distance between two wave fronts, as you can see, uh, is higher or greater than the distance between two crests at a point, for example, here, all right, where the airplane exactly is located. But at a point behind, directly behind the airplane, all right, if you happen to be here, then this wave will be reaching you in such a way that the wavelength is lengthened or increased, and that corresponds to a decrease in frequency or lower frequency of the sound of the airplane. That's why the answer was letter C. All right. You will hear the sound of the airplane Doppler shifted to a lower frequency. A follow-up question, question number 2. An airplane is flying at Mach 1.75 at an altitude of 8,000 meters, where the speed of sound is 320 meters per second. Question is, how long after the plane passes directly overhead will you hear the sonic boom? So in our illustration, we are given the Mach number of the supersonic plane, which is 1.75. And the listener is located on the ground, all right, the altitude of the airplane from the ground is given 8,000 meters. And our target variable is to find the time, how long after the plane passes directly overhead will you hear the sonic boom. All right? Now, in answering this question, we are assuming that the speed of sound, 320 meters per second, remains constant, all right, during the time interval t. All right? This is not actually what happens in reality because it is known that the speed of sound, all right, is affected by the altitude. All right? Uh, the higher the altitude, okay, the lower is the speed of sound. All right? But for simplicity, we just make that assumption that the speed of sound remains constant such that um, the what we call the angle alpha that is formed by the wavefront of the shock wave and the velocity of the source, okay, remains constant. All right. So we are not given um, this distance traveled by the plane, but it is labeled here as the product of the speed of the airplane multiplied by that time t. All right. The angle also is not given. So in a short while, we will be showing how these unknown quantities can be determined and eventually to determine uh, the time, which is our target variable. So for a solution, we first find the angle alpha, right? In the illustration, if alpha is the angle between the wavefront of the shock wave and the horizontal motion of the airplane, okay, that's alpha. The same alpha is also formed between the wavefront and the horizontal ground surface. So that is alpha. Okay, this must also be alpha. All right. In geometry, we have that rule describing two what you call two angles, opposite angles. All right. So uh, we can find that value for alpha using the formula. Angle alpha is equal to arc of the sine quantity 1 over 1.75, where 1.75 is the Mach number. It was earlier stated that the sine of the angle alpha is just equal to the reciprocal of the Mach number. All right? So, with the help of your scientific calculator, we will get the value for the angle alpha equal to 34.8 degrees. All right? Next, we find the speed of the supersonic jet plane, Vs, right? And Vs can just be determined by multiplying the Mach number by the speed of sound, all right? Or 1.75, that's the Mach number, times the speed of sound, 320 meters per second. So we will get the speed of the source, meaning the speed of the supersonic jet plane, equal to 560 meters per second. All right? Now, in the diagram, we can also define the tangent of the angle alpha. All right? Tangent of the angle alpha can also be defined as the opposite side of the right triangle, which corresponds to the altitude 8,000 meters. All right? And that is to be divided by the adjacent side, meaning this distance here. For now, it is represented by the speed of the source multiplied by the time elapsed t, or v sub s times t. All right? That's the equation for the tangent of the angle alpha. All right. And since what we are looking for is the time t, so we can isolate and come up with the working formula for the time t. It will just be equal to 8,000 meters to be divided by the product of 560 meters per second and the tangent value of 34.8 degrees. So doing our math, we will get the value of the time t equal to 20.5 seconds. And that is an answer to our question. All right? The time it takes for the shock wave, all right, to be detected by the listener in the form of what we call a sonic boom. 20.5 seconds after the supersonic airplane has just passed directly above you at the height of 8,000 meters. So that concludes our tutorial for today. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.